Good day, sir. Today I am going to present my answers for the quiz 1 of our subject. The first item is find the value of the 6 trigonometric function of angle theta in each figure. So the first figure is so the first figure is a right triangle which has an an opposite side of which measures 3 and an adjacent side whose measures who which measures whose measures that measures 4 whose value. So the first figure is a right triangle that has an opposite side which measures 3 and an adjacent side who measures 4. So we are going to look for its hypotenuse side. So to look for the hypotenuse side, we are going to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Let a be the opposite side and b be the adjacent side, and c be the hypotenuse side. Now let's substitute the values. So for RA, which is the opposite side, it would be 3 squared. For the adjacent side, it would be 4 squared equals to c squared. 3 squared is 9. 4 squared is 16 equals to c squared. 9 plus 16 is 25. C squared is equal to 25. And we need to cancel out the squared sign for the c. So we are going to use the square root. Square root of 25 is 5. And the square root of c, since c is squared, it will going to cancel. So since squared will be cancelled by the square root, this will going to be the value of r. This will be c, and the value of RC, the hypotenuse side, is 5. So now that we found the value of our hypotenuse side, we can now look for the values of the 6 trigonometric functions of the angle theta. Now, to look for the 6 trigonometric functions of the angle theta, so it is the sine, cosine, tangent, cosecant, secant, and cotangent. So the sine, cosine tangent. So tangent So to look for the sine, sine is opposite over hypotenuse. So the opposite is 3 and our hypotenuse is 5. So our sine is 3/5. For the cosine, it's adjacent over hypotenuse. So our adjacent 4 and our hypotenuse 5. So our cosine is 4/5. Now tangent is equal to opposite over adjacent. So the opposite is 3 and our adjacent is 4. Our tangent theta is 3/4. Now for the cosecant, secant, and cotangent, they are the reciprocal of sine, cosine, and tangent respectively. So for our cosecant, it would be hypotenuse over opposite. It is the reciprocal of mali. So for our cosine, it is the reciprocal of the sine. So it is 1 over sine theta. So the value of our sine is 3/5. So it will going to be 1 over 3/5. And it will going to become 5 over 3. Now for our secant, it is the reciprocal of the cosine. So it is 1 over cosine theta. The value would be 1 over the value of our cosine, which is 4/5. It's going to become 5 over 4. Now for our cotangent, it is the reciprocal of our tangent. It will going to become it's equivalent to 1 over tangent theta, and its value is 1 over the value of our tangent, 3/4, and it will going to become 4 over 3. So these are the 6 trigonometric functions of angle theta in figure A. So our sine is 3/5, the cosine is 4/5, tangent is 3/4, the cosecant is 5/3, the secant is 5/4, and our cotangent is 4/3. Now for our next figure, it is a right angle with the opposite side of 3 and an adjacent side of 3. Now we are going to look for its hypotenuse since it doesn't have any value. So we are going to find its value. To look for the value of the hypotenuse, we are still going to use the Pythagorean theorem since it is a right triangle. So it's going to be a squared plus b squared is equal to c squared. So let A be the opposite, B the adjacent, and C be the hypotenuse. So the value, let's substitute the values. So A would be 3 squared, B is 3 squared equals to C squared. 3 squared is 9. 3 squared, another 3 squared for B, 9. It is equal to C squared. 9 plus 9, 18. Is equal to C squared. And since we are going to square this to cancel out the squared of the square power, the squared of C is going to be, since 18 is not a perfect square, we are going to look for its factors, which is 9 and 2. So since 9 is a perfect square, we are going to write down its value. 9 square root of 9 is 3. And we are going to bring down square root of 2 since it isn't a perfect square. And we will remove its squared sign and the square root sign since both of them cancel each other out. So the value of C is 3 square root of 2. Now this is the value of our hypotenuse. So our hypotenuse is 3 square root of 2. So now that the sides of our triangle is complete, we can now look for the sixth trigonometric function of angle theta in this figure. First, look for this value of sine theta. So our sine theta, which is the opposite over hypotenuse, it would be 3 over 3 square root of 2. But since we shouldn't have a radical in our fraction, we are going to rationalize our denominator to remove the radical. So to rationalize, we are going to multiply it by 1. So 3 over 3. And our value of 1 here would be square root of 2 over square root of 2. So we are going to multiply it, and it would be 3 would be equal to 3 square root of 2. 3 square root of 2 times square root of 2 would be 3 square root of 4. 3 square root of 2, we're going to copy the numerator. And then, for the denominator, 3 square root of 4. Square root of 4 is a perfect square. So, the value of square root of 4 is 2. So, we are going to substitute the value of 2 into 2. So, it would be 3 times 2. Let's still copy the denominator since we can't really do something about it because 2 is not a perfect square. So 3 times 2 for the denominator would be 6. And we are going to simplify this now. So 3 divided by 6, 3 and 6 have a common it's a common multiple, so it will going to become square root of 2 over 2. Since 3 and 6 have a common multiple of 3, so like 3 times 3, 3 times 3. Since 3 divided by 3 is 1, and 6 divided by 3 is 2. So the value of our sign here in this figure is square root of 2 over 2. So now for our cosine is, remember that cosine is the adjacent over the hypotenuse. So our adjacent here is 3 and over 3 square root of 2 for the hypotenuse. Now, we can see that our sine theta and our cosine theta have the same value, which is 3 over 3 square root of 2. So we can now say that this value for our cosine theta will undergo the same process as the sine theta earlier. So we can now say that, from that, we can now say that our cosine theta, which has a value of 3 over 3 square root of 2, can also be simplified as square root of 2 over 2. Now for the next trigonometric function is the tangent theta. So for a tangent, it would be the opposite over the adjacent. 3 for the opposite and also 3 for the adjacent. So 3 over 3, we can also say that it is 1. So for a tangent, it is 1. Now for our cosecant, is the reciprocal of our sine. So since our sine earlier is 3 over 3 square root of 2 from the values from our figure, we can say that our cosecant theta is 3 square root of 2 over 3. Same goes for the secant, which is the reciprocal of our cosine. And it would become 3 square root of 2 over 3. Now for cotangent, it would still be 3 over 3 or 1. Since our cotangent theta here is the reciprocal of our tangent theta, and our tangent theta has a value of 3 over 3, and if you reciprocate it, it will become still 3 over 3. So our cotangent here is 3 over 3 or 1. So that would be the answers for the item number 1 of the quiz 1. Now for item number 2, use the definition or identities to find the exact value of each of the remaining trigonometric functions of the acute angle theta. First value here would be sine theta, which is equal to square root of 2 over 2. Now let's look for the other remaining trigonometric functions, which is the cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Now first, let's look for the cosine theta. we are going to look for the cosine theta using the Pythagorean identity. Using the Pythagorean identity of sine and cosine. So it would be sine squared theta plus cosine squared theta is equal to 1. So we have the value of our sine here, and we are going to look for the value of our cosine theta. So let's substitute our given values. So sine squared theta, we can substitute our value of sine here, sine theta here, will become square root of 2 over 2 squared plus cosine squared theta is equal to 1. Now let's simplify our fraction here. So square root of 2 times square root of 2 is square root of 4 over 2 square root of 2. 2 squared is 4 plus cosine squared theta is equal to 1. The square root of 4 over 4 can be simplified. So it can be simplified, and it can be simplified into, what is the square root of 4? Square root of 4 is 2 over 4 plus cosine squared theta is equal to 1. 2 over 4 can also be simplified into 1/2. I'm going to write that equal to 1. Copy the rest of our formula. So 1/2. So we ended up with 1/2 plus cosine squared over theta is equal to 1. But that is not our final answer. We are going to combine like terms. So we are going to transfer 1/2 into the other side of our equality sign, and it will going to become cosine squared theta is equal to 1 minus 1/2. And after that, cosine squared theta is equal to 1 minus 1/2. 1 minus 1/2 is 1/2. Cosine squared theta is now equal to 1/2. Now we are going to square this. We are going to square both sides because we wanted to remove this square on the cosine. Going to get cancelled. So cosine theta is equal to square root of 1/2. It will going to become square root of 2 over 2. And then this is now our value of cosine theta. Square root of 2 over 2. So how did it became, so how from 1/2, square root of 1/2, it became square root of 2 over 2. So from 1/2, square root of 1/2 rather, we are going to square root them, to put the square root sign individually. So 1 and 2, square root of 1 over square root of 2. So square root of 1 leaves us with 1, and square root of 2 leaves us with still square root of 2. Now, since we can't have a radical for a denominator, we are going to rationalize it. So 1 square root of 2 multiplied by square root of 2 over square root of 2 to become square root of 2 over square root of 4. 2 times 2 is equal to 4. Square root of 4 has square root of 2 isn't a perfect square, so still square root of 2. Now the denominator, for denominator 4 is a perfect square, so square root of 4 leaves us with 2. That's why our cosine theta is equal to 2 square root of 2 over 2. So we have now the value for our cosine theta, which is square root of 2 over 2. Now for the next trigonometric function, we are going to look for the tangent theta. And to find tangent theta, we are going to use the quotient identity, which is tangent theta is equal to sine theta over cosine theta. Now, our sine theta is equal to square root of 2 over 2, while our cosine theta is also square root of 2 over 2. So, let's substitute. Tan theta is equal to square root of 2 over 2 over the value of our cosine, square root of 2 over 2. So we know that if the numerator and the denominator have the exact same value, it is always equal to 1. So our tangent theta is equal to 1. Now that we have our cosine theta, the value of our cosine theta, and the value of our tan theta, we are now going to look for our fourth trigonometric value, which is the secant theta. So to look for secant theta, we are going to use the reciprocal identity. So the reciprocal identity would be secant theta is equal to 1 over cosine theta. Since we need to remember that secant is the reciprocal of the cosine. So so now that we have our value of the cosine theta here, let us substitute our values now. secant theta is equal to 1 over square root of 2 over 2. Next, we are going to 1 over square root of 2 over 2 will become 2 over square root of 2. Now that we have a radical as our denominator, we are going to rationalize it since, as I've said earlier, we shouldn't have a radical for a denominator. So let's rationalize it. Become 2 over square root of 2 multiplied by 1 to square root of 2. It's going to become 2 square root of 2 over square root of 2 times square root of 2, square root of 4, 2 square root of. After this, we're going to copy 2 square root of 2, and square root of 4 is a perfect square, so square root of 4 is equal to 2. And since 2 over 2 are the same values, and if you're going to divide them, it will equate to 1. We're going to remove this. So our second, now we are left with one value and b square root of 2. Since it is the remaining value and it doesn't, square root of 2 isn't a perfect square, we are going to leave it as it is, and it will now become the value of our secant theta. So our secant theta is square root of 2. Now for our fifth trigonometric function, it is cosecant theta. So to look for the cosecant theta, we are going to use the reciprocal identity, which is cosecant theta is equal to 1 over sine theta. So let's remember that. As I said earlier, cosecant is the reciprocal of the sine. So now let's substitute our values of cosecant, values of sine. Cosecant theta is equal to 1 over sine theta is square root of 2 over 2. So the same from our secant earlier, cosecant 1 over square root of 2 over 2 will become 2 square root of 2. And then we're going to rationalize this since it has the same values as the secant. We can say now that 2 over square root of 2, if it is rationalized, it will going to become square root of 2. So the cosecant and the secant have the same value, which is square root of 2. Now for our last trigonometric function, for the sine theta is equal to square root of 2 over 2 is the cotangent theta. So cotangent, to look for the cotangent theta, we are going to use the reciprocal identity, which is 1 over tangent theta. Since cotangent is the reciprocal of the value of tangent theta, since we have now the value of our tangent theta, Let us now substitute. Cotangent theta is equal to 1 over 1. 1 over 1 is simply equal to 1. Now our cotangent theta is equal to 1. So now the 6 trigonometric functions are complete. For our sine theta, square root of 2 is equal to square root of 2 over 2. Our cosine theta, it is equal to square root of 2 over 2. The tangent theta, which is equal to 1. The secant theta, which is equal to square root of 2. Our cosecant theta, which is equal to square root of 2. And the cotangent theta, which is equal to 1. For our next trigonometric function, we have tangent theta is equal to 1/2. Now we are going to look for the sine theta, cosine theta, cosecant theta, secant theta, and cotangent theta using the definition of tangent. So what is the definition of a tangent? Tangent is equal to the opposite over the adjacent side of our triangle. Since we have the value of our tangent here, which is 1/2, we can say that the opposite is 1, and the value of our adjacent is 2. Now the only thing missing here is the value of our hypotenuse. So to look for the value of our hypotenuse, just like in the item number 1 earlier, we are going to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now, let A be our opposite, B our adjacent, and C be our hypotenuse. So let us now substitute our values. So A would be our opposite, which is 1 squared. B plus B squared. Our B is the adjacent. So the value of our adjacent is 2. We're going to write 2 squared. And then it is equal to C squared. 1 squared is still 1. 2 squared is 4. Is equal to C squared. 1 plus 4 is 5. Is equal to C squared. Now to remove the squared sign on our C, we are going to square root both sides. So 5 doesn't have any square root. It isn't a perfect square, so we're going to write it as it is, square root of 5. And while our C here, since it has a squared here, it is going to get cancelled by our square root. So we are only going to write C here. So now our value of C, or our hypotenuse is square root of 5. Now that we have our values now for the opposite, adjacent, and the hypotenuse, for our opposite, we have we have 1. For our adjacent, we have 2. And for our hypotenuse, we have square root of 5. With these values, we can now look for the 6 trigonometric functions left. So for our sine, since sine is equal to opposite over hypotenuse, the value of our sine here is 1 over square root of 5. Now we remembered that we can't have a radical on our denominator. We are going to simplify it by rationalizing our denominator. We're going to become our sine will become from 1 over square root of 5, it became square root of 5 over 5. For cosine theta, our cosine is equal to the adjacent over the hypotenuse. The adjacent over the hypotenuse, so we have 2 over square root of 5. Same for our sine. We can't have a radical as a denominator. So, same process, we're going to rationalize it. Now, our cosine here, from 2 square root of 5, we rationalized it. It became 2 square root of 5 over 5. Now, our tangent is equal to 1/2. Now, we have our cosecant. Our cosecant is the reciprocal of the sine. So, we have 1 over the value of our sine, square root of 5 over 5 will be equal to 5 square root of 5. We are going to rationalize the denominator since it is a radical. We need to multiply it by 1. 5 over square root of 25 is equal to 5 square root of 5 over 5. 5 divided by 5 is 1, so that would leave us with square root of 5 as the value of our cosecant. Now for our secant is the reciprocal of our cosine. So we have our cosine here, 2 square root of 5 over 5. So now we can have the square root of 5 over 2. Now for our cotangent is the reciprocal of our tangent, which which is 2. Now, we have now the 6 trigonometric functions for so now we have our 6 trigonometric functions. The tangent, the given is tangent theta is equal to 1/2. Our sine, that is equal to square root of 5/5. Our cosine, which has the value of 2 square root of 5/5. Our cosecant, which has the value of square root of 5. Our secant, which is square root of 5/2. And our cotangent, that has the value of 2. Now for our next item, item number 3, given that sine 30 degrees is equal to 1/2, use the trigonometric identities to find the exact value of cosine squared 30 degrees. So, to find cosine squared 30 degrees, the exact value of cosine squared 30 degrees, we are going to use the Pythagorean identity. So the Pythagorean identity we're going to use would be sine squared theta plus cosine squared theta is equal to 1. Since we have our sine, the value of our sine, and we are going to substitute the value of our sine into sine squared theta. This is going to be 1/2 squared plus cosine squared cosine squared 30 degrees is equal to 1. 1/2 squared is 1/4 plus cosine squared 30 degrees is equal to 1. So now we are going to group like terms. So cosine squared 30 degrees is equal to 1 minus 1/4. We moved 1/4 to the other side of our equality sign. Cosine squared 30 degrees is equal to 1 minus 1/4 is 3/4. So now we are going to square this. Cosine squared 30 degrees. It's going to become cosine 30 degrees equal to the square root of 3/4 would become square root of 3/2. Now we have the value of our cosine 30, but we need to find the value of cosine squared over 30. Now, to find the value of our cosine squared 30, we are going to square the value of the cosine 30 degrees to find the value of cosine squared 30 degrees. So, the value of our cosine 30 degrees is cosine 30 degrees is equal to square root of 3/2. Squaring this, we need to square this to find the value of cosine squared 30 degrees. So squaring this, we are going to have 3/4. We have our value of cosine squared 30 degrees, 3/4. Now for our next item number 4, simplify each expression for the given value of x. assume that angle theta is a cube. So for this item, our expression would be square root of 25 minus x squared. If x is equal to 5 sine theta. Now to simplify this expression, we are going to substitute the value of x. So it should become 25 minus the value of x. We have 5 sine theta squared. Then after this, we are going to square this expression. Value. We are going to square 5 sine theta. 5 squared would be 25. And sine theta squared would be sine squared theta. So still square root. After that, we are going to use the Pythagorean identity. The Pythagorean identity sine squared 0 theta is plus cosine squared theta is equal to 1. Now we are going to rearrange this into this identity or this formula into 1 minus cosine squared theta. Still square root. Now after that, we are going to distribute 25 over here in the parenthesis. 25 minus 25 times 1 would become 25 plus 25 times cosine squared theta would become 25 cosine squared theta. Still, not forget to put a radical symbol here. So after this, we are now going to combine like terms. So 25 minus 25 would become 0. So 0 and we are now only going to write 25 cosine squared theta. Still the radical symbol. And now we are going to simplify this. So 25 is a perfect square, so it's going to become 5. And then cosine squared theta, since our cosine here has a is squared, this exponent and this radical symbol cancels out each other. So they are now gone. Now the value of r, this would be now our final answer. 5 cosine theta is our final answer. Now, if you're going to simplify, square root of 25 minus x squared, if the value of x is 5 sine theta, the answer would be 5 cosine theta. Now, for our fifth item, this is a word problem, and the problem goes, at a certain time of the day, the angle of elevation of the sun is 40 degrees. To the nearest foot, find the height of a tree whose shadow is 35 feet long. So this is our figure here. So the angle of elevation of the sun is 40 degrees, and our shadow here, we have a shadow here which is a 35 feet long. So to find the height of the tree, so the height of our tree here, we are going to use the formula tangent 40 degrees is equal to the height of the tree over 35, which is the length of the shadow. So we are going to rearrange this, since we are looking for a height, not the tangent. So we are going to rearrange this into height. BH is equal to tangent 40 degrees times 35. H. Now we are going to calculate this. So tangent 40 degrees times 35. If you using a calculator, if you multiply these two, it is equivalent to 29.368. So the height of our tree is approximately 29.368. Now for our last problem, the last problem or last item, it is still a word problem. So the problem goes, a road is inclined at an angle of 5 degrees. After driving 5,000 feet long along this road, find the driver's increase in altitude. So we're going to look for the height of the road he is taking. So this is now our figure or drawing of the problem. So we have our angle here, since as the problem said, increasing at an angle of 5 degrees. So this is increasing at an angle of 5 degrees, and then the driver is driving 5,000 feet. So from here to here it is 5,000 feet. So to look for the height, we are going to use height is equal to distance times or multiplied by sine 5 degrees. So H stands for the height, which is what we are going to look for, and D is the distance. The distance the driver traveled along. So we are now going to substitute our values. For the distance, we have 5,000 feet long, and for the and copy the sign 5 degrees. So if you're using a calculator, 5,000 times or 5,000 multiplied by sine 5 degrees is equal to 435.5. So the height of the altitude we are going, the altitude the driver is now going is 435.5. So that would be all for my answers in quiz 1. Have a good day.